But why doesn't Intel package these chips as running faster? Because if you run a computer game and something goes wrong, worse comes to worse, your enemies slay you, and you have to start again. If this is a chip running on the real space station, and it runs faster and something goes wrong, one operation does not have time to come before the other, what's happening? God forbid what's happening. So we better not do that. So the big question there is not so much how fast the chip runs, but how fast can it guarantee to finish all the operations, and there are tons of possible operations inside. This is where interval computations are used. This is where they lead to good results. Second example, bioinformatics. Bioinformatics is the following. For example, when people study cancer, this is actually coming from the real example. They want to find genetic differences between cancer cells and healthy cells. Because the problem with cancer is, unlike all other diseases what? What's flu? You have a virus coming into your body. This virus is completely different from you. The body is sick. It's silly, cannot recognize it, but it's different. Cancer, unfortunately, is your own cells revolting against you. And they're slightly different, but not completely. It's very difficult to find the difference. So, it would be nice. What do? You take sample from the tumor, you take sample from the healthy tissue, you compare. The problem is, the tumor is not just cancer cells. It's a mixture of cancer cells and normal cells. So, what you have is not a concentration in the tumor, in the cancer cells, but it's a combination of the concentrations in the tumor and in the healthy cells. And this concentration is not known. How it is determined, you wouldn't believe it. Somebody looks under the microscope, determines the shape of these cells. Just like when you, God forbid, get something on your skin, you go to the doctor. Does the doctor have a cancerometer applied to you? No. The doctor looks at it and says, this looks regular. If you want, I can give you cosmetic surgery, cut it off. Or the doctor says, you know, it's very suspicious. Why don't we cut it off? Or the doctor says, we need further tests. But it's very subjective. If you go to another doctor, he may give you completely different results. So this is exactly the problem. So all we have is an interval here. It's a guarantee. And this is unfortunately, no probabilities or anything. It's very subjective. And so what we need to do is to find in this way. Another example is outlier detection. So we want to know, for example, like a bridge is built or whatever it is. There is some parameters. You know when it's stable. You know when it's not stable. If you knew exactly the parameters of the bridge, you would predict. Unfortunately, you don't know the exact parameters. You know the bounds. In this case, what do? What we need to do is to produce exactly the interval. And it depends. If it's a bridge, we better make sure that for all values within that interval, everything works. Okay, next I'm going to Dr. Longpre's talk, so I think he can take over. But intervals are related to what he will be taught.
Questions for me?
Questions for me? Okay.
I have one.
Okay.
This looks very, very complicated. I'm just a starting master student. If I work with you, what can I do?
Well, let me put it this way. Okay. Okay, this is one of the cases where, so what can you do? There are several things. One is going ahead and doing some complicated mathematics which nobody has done before. This is something that I'm not advising all of you to do, but if you're really interested in that, be my guest. A second, much more interesting area for most of you is applications. Because I just mentioned the general problem. The specific problems are, there are a lot of applications, like in CyberShare project that we're having now, we are processing ecological data, we are processing geological data. You don't really need, I shouldn't have said it. You don't really need to know anything about geology or ecology, at least to start working. Of course, you need to learn something, you can get it and everything. But this is the idea. What you need to, there's a lot of practical problems in which it doesn't tax that much your mathematical abilities. All you need to do is to kind of run the code, test it, compare it, and just see how it goes, because the methods already exist. Okay? If you develop new methods, be my guest, that will be a wonderful PhD dissertation. If you don't develop new methods, it's still a very good master thesis, and many students did that for privacy and for other applications. Did I answer? Okay. Did I convince the starting master student? And you can have all the help you want. I mean, that's not like I want you to see this one. Okay?